You think space is large? That intuition is nowhere close. The observable universe spans about 93 billion light-years from one side to the other, and even that enormous figure may represent less than 1% of everything that actually exists. Before we reach that idea, though, let's establish a sense of scale. Imagine the sun reduced to the size of a bowling ball. Earth would become a tiny grain of sand circling it from roughly 30 meters away. On that model, the nearest star would not be somewhere across your town, it would be on the other side of the Pacific Ocean, and that would account for only the nearest star. Our galaxy contains at least another 100 billion. Everything in this sequence is real. These distances are based on measurements, not invented for effect. By the time we reach the larger scales, the size of the universe will seem less like a number to admire and more like a condition astronomers have had to accept. Begin with our own planet. Earth measures about 12,742 kilometers across. It feels vast, yet no person has ever stood in a position where they could see the whole world directly with their own eyes. The Moon, our nearest natural companion, circles Earth at an average distance of about 384,000 kilometers. That empty space between us and the Moon is so wide that every other planet in the solar system could be placed side by side inside it with some room left over. Now pull the view farther back. The Sun lies approximately 150 million kilometers away. Light travels faster than anything else known, and even light takes about 8 minutes to cross that distance. So when you watch a sunset, you are not seeing the sun exactly as it is at that moment. You are seeing sunlight that began its journey roughly 8 minutes earlier. The sun in your sky has already moved on by the time its image reaches your eyes. Continue outward and the distances become difficult to hold in your mind. Jupiter, Saturn, Uranus, and Neptune spread across a planetary system that reaches roughly 4.5 billion kilometers from the Sun. Sunlight needs more than 4 hours to reach the outermost planet. When the Voyager 2 spacecraft passed Neptune in 1989, the radio messages it sent back traveled at the speed of light, yet still required about 4 hours to make the trip home. Neptune seemed like the boundary of the solar system, and from a human perspective, it felt almost like the boundary of everything. But Neptune was not even the beginning of the truly remote regions. Beyond it lies the Kuiper Belt. Farther still is the Oort cloud, a vast shell of frozen material that may extend perhaps halfway to the next star. Everything humanity has ever touched, photographed, or physically explored remains inside a region that light can cross in roughly a single day. Then consider the galaxy. The Milky Way is about 100,000 light-years wide. To make that size imaginable, shrink the entire galaxy until it is the width of the United States, stretching from coast to coast. Under that comparison, the whole solar system would be about the size of a coin. The Sun, all 8 planets, and every spacecraft humanity has launched would be represented by a single quarter resting somewhere in Montana. The territory from New York to Los Angeles would still be space no human being has entered, and almost certainly never will. That quarter marks the end of the map. Not the end of the universe, but the end of direct human experience. Every war, every love story, every idea ever formed by a human mind has taken place on a grain of sand within that coin. Looking at a tidy diagram of the solar system can feel reassuring because maps make enormous spaces seem manageable. But a map only remains comforting when you have not yet considered everything it excludes. The Milky Way makes the omissions impossible to ignore. Go outside on the darkest night you can find, far from cities, beneath a clear and exceptionally dark sky. At the absolute limit of unaided human vision, you might see around 5,000 stars. The view can feel endless. It may seem as though you are looking directly into the universe itself. In reality, you are seeing something closer to a rounding error. Every star visible without a telescope lies inside a relatively small yellow region surrounding the Sun, a bubble only a few thousand light-years across, embedded in a galaxy that measures 100,000 light-years from end to end. The Milky Way contains at least 100 billion stars. Add together every star visible to the naked eye, and the total still amounts to fewer than 1 out of every 20 million stars in our galaxy. Light itself needs 100,000 years to cross the Milky Way. A message sent from one edge when human beings were still sharpening their earliest stone tools would only be arriving at the opposite edge today. And even the Milky Way is not the universe. It is one island among countless others. The nearest large island is the Andromeda Galaxy, a spiral galaxy containing roughly 1 trillion stars and located about 2.5 million light-years away. The light from Andromeda entering your eyes tonight began its journey before our species existed. Yet Andromeda is considered our neighbor. On a cosmic scale, it is practically next door. It is close enough that, in roughly 4 billion years, the Milky Way and Andromeda are expected to collide. Our local group contains dozens of galaxies. The Milky Way and Andromeda are the largest members, surrounded by a collection of smaller companions. Together, these galaxies occupy a region about 10 million light-years across. That may sound like an entire universe when viewed from Earth. It is more like a village. And that village belongs to a city. The larger structure is associated with the Virgo supercluster, which itself forms part of something larger again, Laniakea. This enormous structure contains approximately 100,000 galaxies, all flowing through space in a pattern that can be compared to water moving toward a basin. The basin toward which these motions appear to converge is known to astronomers as the Great Attractor. Laniakea stretches across roughly 500 million light-years. Within it are 100,000 galaxies, each potentially containing billions of stars. Yet Laniakea is only one supercluster among millions scattered throughout the observable universe, arranged across the cosmos like foam spread over an ocean with no visible end. At this point, many descriptions stop and call the scale inspiring. This is where we have to stop treating the observable universe as though it were the whole universe. The observable universe is a sphere about 93 billion light-years across, centered on every observer, including you. That does not mean you occupy a special location. It simply reflects how far light has been able to travel toward us since the beginning of cosmic time. Its edge is not a physical wall. It is a horizon, the boundary of what can be seen, not the boundary of what exists. And this is where the picture changes again, because space itself is expanding. That is different from galaxies merely traveling through an unmoving void. The space between distant galaxies is stretching everywhere at once. For that expansion, there is no simple speed limit in the same sense that there is for objects moving through space. If two regions are far enough apart, the distance between them can grow faster than light can cross it. Nothing is violating the laws of physics. No object is locally moving through space faster than light. Instead, the space separating those objects is increasing so rapidly that light cannot make up the growing distance. Consider the consequence. There are galaxies out there, real galaxies filled with stars and planets, whose light is traveling toward us at the maximum speed the universe permits, and still losing the race. The space between those galaxies and us expands faster than their photons can close the gap. Their light will never arrive, not after 1 trillion years, and not after any longer period of time. Astronomers have calculated what this means, and the result is one of the bleakest numbers in cosmology. Of all the galaxies within the observable universe, approximately 94% have already crossed the boundary beyond which communication is impossible. We can still observe their ancient light because that light left them billions of years ago, before expansion carried them beyond our future reach. But the galaxies themselves, as they exist now, are permanently outside any possible contact. No signal we transmit will ever reach them. No signal they send today will ever reach us. They are not concealed behind dust, and they are not simply very distant in a way that more powerful technology could overcome. They have been cut off from us by the expansion of space itself. All we can do is watch the ghostly light from their earlier history fade across the sky. Even this horizon does not stay in one place. With every passing second, additional galaxies cross beyond it. The universe is not merely larger than the part we can observe. More of it is actively slipping away from observation and contact. So the central question is no longer, how large is the observable universe? The more unsettling question is how much exists beyond that horizon, in the region we will never be able to see. The most honest answer is also the one most difficult for cosmology to live with. Cosmologists do have methods for estimating the size of the universe as a whole, the real universe, including everything beyond our observable horizon. They measure the curvature of space. They examine the afterglow left by the Big Bang. They compare observations made across enormous distances. And every result points in essentially the same direction. Space appears to be flat, or so close to flat that no curvature has been detected. A flat universe has no natural overall size. It has no obvious reason to end. Even the more cautious models of cosmic inflation, grounded in established physics, place the actual universe at least hundreds of times larger than the portion we can observe. Other models stretch that estimate much farther. In the most dramatic versions, imagine shrinking the observable universe until it becomes a marble you could hold. The universe as a whole, by comparison, would be as large as a planet. And even that enormous picture may still be too small, because the available measurements are also compatible with an idea that is simpler in one sense and much stranger in another. The universe could be infinite. No boundary, no outer wall, no final point where space runs out. Galaxies extending forever in every direction. Infinity is not merely an especially impressive number, it changes the rules of what follows from the universe's size. Within any limited volume of space, matter has only a finite number of ways to arrange itself. But if space continues without limit, then every one of those arrangements must appear somewhere. Not merely as a possibility, it has to occur. That means that somewhere unimaginably beyond our cosmic horizon, there would be a region exactly like this one. There would be a galaxy indistinguishable from ours, a world indistinguishable from Earth, and a person indistinguishable from you. The same face, the same memories, the same thoughts unfolding at this precise moment. Far away, that duplicate may already have reached the end of this recording. This sounds like science fiction, but under the infinite universe assumption, it follows directly from mathematics. Working cosmologists take the possibility seriously, not because it is a fantasy they enjoy, but because it may be the consequence of interpreting the data in the simplest way. And while that idea is sinking in, the universe adds another complication. Dark energy, the still unexplained influence associated with cosmic expansion, is not gradually weakening. The expansion is accelerating. Space itself is stretching faster and faster. With every passing second, more galaxies cross beyond the horizon that can ever send us information. At the same time, the share of the universe that remains available to our future knowledge becomes smaller. We arrived at the cosmic party just as the guests began disappearing through the door. In the distant future, an astronomer born somewhere in our galaxy may look outward and find absolutely nothing beyond it. Every other galaxy will have receded beyond reach. Every observation that now demonstrates cosmic expansion will have vanished from view. With flawless instruments and sound reasoning, those astronomers could conclude that their galaxy is the only one that exists. Their conclusion would be wrong, yet there would be no evidence left that could reveal the mistake. So consider, without softening it, where you are located. You occupy a tiny grain of sand circling a bowling ball, inside a coin lost somewhere in Montana, on one island containing roughly 100 billion stars. That island belongs to a village of galaxies, which itself sits inside a larger structure containing roughly 100,000 more. And all of it is enclosed within a visible horizon that conceals at least 99% of everything that exists, and perhaps an infinite amount beyond that. The unseen portion is moving away from us faster with every second, becoming permanently inaccessible. By any ordinary measure, you should be insignificant. The numbers are not simply unfavorable, Scar. The numbers do not register your existence at all. Yet you are part of this universe that calculated the numbers. Across all that quiet, expanding immensity, atoms on this single grain of sand came together into something that opened its eyes, looked into the darkness above, and asked how large it was. The universe is too vast for any mind to grasp completely, and somehow it produced within you the one known thing that has attempted to grasp it. Every galaxy beyond our horizon will continue expanding into darkness without being observed. No one will count the stars within those galaxies. No one will give names to their planets or record the histories that may unfold there. But this galaxy has a witness. This one does. The odds against your existence are so extreme that describing them as astronomical almost diminishes what the word astronomy means. Even so, you are here, seeing the scale of it. That is more than a consolation prize. As far as we know, conscious awareness of the universe may be the rarest event the universe has ever generated. So if someone tells you that space is big, you will understand why that description fails. Big was never the right word. The region we can observe, roughly 93 billion light-years across, filled with more galaxies than we can count, could be no more than a marble lying on the surface of something that has no end. And then comes the strangest feature of all. Trillions upon trillions of stars are shining right now, in every direction. Yet, when you step outside and look upward at night, the sky is dark. Not merely dim, but almost perfectly black. With that many stars burning across the cosmos, the entire sky ought to glow like the surface of the sun. It does not. The explanation is one of the most unsettling answers astronomy has ever uncovered. The universe conceals nearly all of what it is, and the reason it remains hidden is on your screen now.